Hello everyone, I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to discuss what is linear programming problem and various types of linear programming problem along with its components and assumptions of linear programming problem. Coming to the definition of linear programming problem, linear programming problem is a kind of method or technique which is used for optimization. That is why it is also called optimization technique, in which we use mathematical modeling to solve the problem which involves or includes limited resources, which in turn we call it as scarce resources. So, when an organization is dealing with scarce resources, and if it is a question of allocation of these scarce resources among competing activities in the business organization in order to maximize the output or to minimize the cost, then this linear programming comes into picture. So, such kind of a problem, that is allocation of scarce resources, can be dealt with this mathematical modeling which is called linear programming problem. And coming to various types of linear programming problem, we have manufacturing problem. So, when in the production unit or the companies which are into manufacturing of the products, so they come across with several resources like time, manpower, machines, several resources, several inputs which are limited in nature, and these different resources are to be used for allotted for different competing activities. There we come across with this linear programming problem. And in case of diet problem, when it is a case of diet problem, how much protein is to be given and what kind of resource in how many quantities it is to be given in order to maximize the protein or in order to make it to a limited extent. Okay, there also we can make use of this linear programming problem. Assignment problem, job sequencing problem, transportation problem, all these are various kinds of linear programming problem. And coming to the basic terminologies, in linear programming problem, we come across with several concepts which commonly used in this linear programming problem. The first one is decision variables. What is decision variable? Decision variables are the variables, the number of quantities that are to be determined or defined. So, that is the term itself suggesting meaning, these are the variables regarding which the company has to take the decision in terms of how many units are to be produced or manufactured. And also in linear programming problem, we also come across with another term, that is objective function. So, what is an objective function? Objective function is that function which needs to be optimized. So, what is the meaning of optimization? If we consider a business organization, every business organization will have two objectives, that is either to maximize the profit or to minimize the cost. Either the firm can maximize the profit or it can minimize the cost. So, these two could be the objectives of a business organization. The objective of, in order to maximize or minimize, we put the decision variables in terms of a linear function which is called mathematical model, and that is called objective function. And next, constraints, that is conditions. Already we have understood that the business organizations deals with limited resources, that is scarce resources which are limited in nature, which are not available abundantly. These scarce resources are to be allotted across different competing activities. Formulation of these conditions in terms of the given limitations is called constraints. And the other one is feasible solution. Every linear programming problem may have only one solution, that is unique solution, or sometimes it may have multiple solutions. Several solutions also may exist for a linear programming problem. So, the set of all possible solutions of a linear programming problem is called feasible solution. All the possible solutions satisfying the constraints is called the feasible solution. And coming to optimal solution. So, the main agenda of linear programming problem is to find out the solution, that is how many units of each resource is to be allocated in order to maximize the profit or to minimize the cost. Each resource, how many units is to be allocated within the limitation by satisfying the conditions. So, that is the ultimate agenda of the linear programming problem, and that we can do with this optimal solution. Optimal solution is that solution which is the best solution among the possible solutions is called optimum solution. So, these are the main things or the terminologies which we come across in linear programming problem. Coming to the application part, let us try to understand where this linear programming problem comes into picture. So, there is a garment, if we consider this problem, there is a garment manufacturer who is producing two styles of shirts, and style 1 needs 200 grams of cotton. If we observe this problem, the manufacturer is using different types of resources, different types of threads: cotton thread, Dacron thread, linen thread. 3 types of threads that the manufacturer is using, and he is producing 2 styles of shirts, style 1 and style 2. In order to produce manufacture these 2 styles of shirts, the manufacturer is using 3 types of threads, that is cotton, Dacron and linen. Here we are given that style 1 needs 200 grams of cotton, 300 grams of Dacron and 300 grams of linen thread. Correspondingly, we are also given that style 2 requires 200 grams of cotton, 200 grams of Dacron, 100 grams of linen thread. And the net contributions are, that is the contribution means the contribution of each style. So, that is the profit upon 1 unit of style 1 shirt, that it is going to be 19.50 rupees, and the contribution of style 2 is going to be 15.90 for style 2 shirt. The available inventory of cotton thread, cotton, Dacron and this linen thread is 24 grams, 26 and 22 grams respectively. That is, to manufacture these 2 style of shirts, the company is using 3 types of threads. And so, what is the total quantity of each thread that is available with the company to produce, to manufacture these 2 types of shirts? That is 24 kgs of cotton thread is only available. Not more than 24 kgs of cotton thread is available with the company. By using less or equal to this 24 kgs of cotton thread, the firm has to manufacture both styles of shirts. Okay, and the company is having 26 kgs of Dacron thread only. So, by using this 26 kgs only, the firm has to manufacture 2 styles of shirts, and 22 kgs of linen thread is only available with the company. So, these 3 are the resources here in this problem. And what are the decision variables? So, whenever we are going to talk about linear programming problem, as I said in the previous case, we come across with several decision variables. We use the term objective function, constraints, feasible solution and all. So, in this problem, let us try to understand what is the objective of the company. It is given that the contribution of each shirt is 19.50. So, the firm wants to maximize the profit. The manufacturer wants to determine the number of each style, and the firm wants to determine the number of each style shirts should be produced. So, how many shirts of style 1, how many shirts of style 2 are to be manufactured? So, that is the question in front of the manufacturer. So, these are the decision variables. How many number of style 1 shirts are to be produced? How many number of style 2 shirts are to be produced? So, these are the decision variables, and objective function is maximizing the profit upon each shirt. And we are also given that the conditions. Coming to the constraints, the constraint, we can understand that there is only 24 kgs of cotton thread available, 26 kgs of Decron thread is available, and 22 kgs of linen thread only available. The constraint here is upon the thread, that is cotton, Decron and linen. So these are not abundantly available, only 24 kgs, 26 kgs and 22 kgs of these three types of threads are available. Accordingly, we have to formulate the constraints. So this is how a linear programming problem will have different constraints, and this is how the linear programming problem looks like. So if we consider the previous problem, so these are the decision variables. X1, X2 are the decision variables, and the objective function, this is called objective function. So always remember, always the objective function may be in the form of either maximization model or in minimization model. When it is a case of profit, we use objective function as maximum Z, as every firm is interested in maximizing the profits. And if it is a case of cost, so always every firm tries to, in minimum cost, it wants to maximize its production or its output, right? So therefore, if the problem is something related to cost, then we have to use the objective function as minimum Z. So coming to the other part of the linear programming problem, that is constraints. As we have said, the company manufacturer is using three types of threads, and the limitation is the only 24,000 grams, that is 24 kgs of cotton thread only available. So 26 kgs of Decron is available, 22 kgs of linen is available. Accordingly, these are the constraints which, so since we have used here less than or equal to, because cotton thread is not available more than 24,000. Therefore, we have to use the inequality, that is less than or equal to only. So, based upon the conditions or availability of the resources, we have to form this constraint. And we have to form the last part of this linear programming problem is non-negative constraints. What is this non-negative constraint? Non-negative constraint means here X1, X2, we are calling them as decision variables. What is X1 denotes? X1 denotes the number of style 1 shirts to be produced. X2 denotes number of style 2 shirts that are to be produced, right? So, X1, X2 can never be negative. That is, we never say that minus 3 shirts, minus 100 shirts are to be produced. Okay, 0 shirts are to be, if company is 0 means the company is not going to produce any shirt. There is no problem exists. Okay, this kind of problem never exists, right? So therefore, ultimately we should also write the negative, non-negative constraints. So a linear programming problem will have number 1 decision variables and will have objective function and also constraints and finally non-negative constraints. So this is how the linear programming problem looks, and this is the format of LPP, or else we can say. And coming to the conditions, we can also call them as prerequisites. So in order to formulate a problem as a linear programming problem, the problem should satisfy certain prerequisites. If the problem satisfies these prerequisites, then only we can formulate the problem as a linear programming problem. And first one, limited resources. Limited resources means, in the previous case, the firm is only 24 kgs of cotton, 22 kgs of linen and all. So, the resource should not be available abundantly, the resource should be scarce and which are available in limited only. And the other one, objective function. The firm should have the objective, that is either to maximize profit or to minimize the cost. So, that objective should be there in the problem. And next one, linearity. Linearity means if the firm increases certain sum of one input or either of the inputs, it should contribute to an increase in the output also. That is what we call linearity. If we decrease amount of the inputs, consequently their contribution also decreases. The problem should satisfy this condition also. And coming to homogeneity. Homogeneity means the firm might be using several inputs like time, machines, manpower, several other materials might be used by the business organizations. So, all the machines, suppose if we consider machines, the performance of all the machines should be identical, performing different competing activities. So, the performance of the machine should not differ from one activity to another activity. That is what we call homogeneity. And next one, divisibility. That is, if the contribution upon the decision variable x1 is 1, if the contribution of decision variable x2 is 2. So, suppose if the firm is producing 10 shirts, so upon 10 shirts, suppose if the profit is 10, it should be 10 into 10, 100, and if the profit upon x2 is, say for example, 5 rupees, 2x2 means 2 5s 10. So, this is also we can divide, the contribution should be divisible. These are the important prerequisites that are required to formulate a problem as a linear programming problem. And these are the various components of the linear programming. There should be relationship between the decision variables and the relation should be linear in nature. There should be objective function, there should be constraints, and the model should have non-negative constraints. So, these are the prerequisites which are required to form a problem as linear programming problem. And coming to the next part of this lecture, that is formulation of LPP. When we have such kind of a problem, this kind of problem, how to formulate this problem as a linear programming problem in this model. So, let us see step by step how to formulate a problem as a linear programming problem. The first step is identify the decision variables. So, how to identify the decision variables? Here we understood from the problem we can understand that manufacturer wants to determine the number of each style shirts to be produced. So, he has to take decision regarding how many units of each style of shirt is to be produced. Okay. So, these are the decision variables. That is the first step in formulating the problem as LPP. And the second step is write the objective function. Observe the problem, whether it is a case of maximizing the profit or whether it is a case of minimizing the cost. So, if the problem is upon profits, use the objective function as maximum z. If it is a case of cost, use the function as minimum z. Next, third step is write the constraints. So, coming to this problem, so these are the constraints. We should understand what are the, in order to write the constraint, one should understand what are the resources, whether they are available limited or unlimitedly they are available. So, all these things we have to understand, and then we have to formulate the constraints in the form of inequalities or equalities. Next, state the non-negative constraints. The way decision variables must always be greater than or equal to 0, since we never produce negative units or we never use negative quantities. Therefore, we have to finally state the non-negative constraints. So, this is how we can formulate a problem as linear programming problem. By the end of this lecture, we have understood what is linear programming problem and what are the various applications of linear programming problem, various types of linear programming problem, and what are the conditions those are required for formulating a problem as a linear programming problem, and what are the components of LPP, how the LPP looks, and how to formulate the linear programming problem. So, these are the concepts which we have understood by the end of this lecture. Thank you.